Hello friends, welcome to a series of coding interview preparations. So here we begin with the first part of our work, that is about the various data structures we need to work with while coding. The data structures are meant to keep the data in order so that it can be used most efficiently, whether adding a new data or retrieving a data or removing a data, modifying a data, whatever it is. So when these are the various operations we need to perform, and we need an appropriate structure of the data so that it can be operated very easily. So the one of the simplest data structures is an array, and array is used to represent a list of items. So it may be list of numbers, so list of integers, list of floating numbers, or list of characters. So this list of characters can further be called a string, and this string can be put together one after other, and then we have a list of strings, so that the list continues. Many versions are there. So array is a list of items. So when it comes to put the items, the best way is to form some sort of array. In our computer terminology, an array is a sequence of memory locations reserved to store the data. So why we have so many different types of lists? Because when it comes to memory, then for each item there is a different memory requirement. Like if you say in our C version, if you say integer, then integer is used with a 16-bit representation. When you say character, character is usually represented in ASCII code, so that needs an 8-bit representation, and so on. So various different things will have different size of memory requirement. So if you look at how the memory is organized, so when it comes to memory, usually the memory is organized in terms of bytes. That means we have a sequence of bytes available. The width of each memory location is 1 byte. So that's width is 1 byte. That means it can store 8 bits. So there are 8 locations in this, where each location can be stored with either a 0 or a 1. So bit means it will be either a binary 0 or a binary 1. So 8 bits together will form a byte. So that way we have number of bytes. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So the position of your data is usually referred to as address, and what is written in this is usually referred to as data. So that's our basic convention when we talk about storing a group of data of same type into memory. So the best way of using is form an array. So the use of array is identifying any given data. Just look at its position. So if we have numbers like 4 here, 8 here, 10 here, 25 here, 16 here, and so on, then we can say that address of 16 is 4, or at 4 the data stored is 16. So either way you can speak. Either you say at address 4 the data stored is 16, or 16 is stored at location 4. So this are the two ways of working, and many applications of arrays are there, and one of the application of array is to search an item in the array. So if you want to search whether 16 is there in the array, what we can do is a simple process would be, look at the first step, is it 6? No. Is it 6? No. Second step, second position, is it 6? 16? No. Third position, is it 16? No. Fourth, third position, is it 16? No. Fourth location, is it 16? Yes. So we found 16 at location 4. So that's one way of working. So we look from beginning to end in sequence. We search and stop the search when we find it, and return the location where it was found. So we are looking for 16. So first location, so 0 location 16, no. 1 location 16, no. 2 location, no. 3 location, no. 4, yes. So return 4. So that's what we are doing. And there is chance that what you are searching may not be there in your list. So if you reach the end and the item you are looking for is not found, then declare that item not present in the list or array. So what is it saying? So if you find it, so you can stop your journey and just return back the location where you found it. But if you reach end, until you reach end you didn't get it, only then you can declare that it is not present. So to say not present, you have to see the whole list, but to say where it is present, so it is move till you do it. So this type of searching is called linear search. So the best possibility is what you are searching is found in the first location. So order of 1, that's the best possibility. And if you look at of the worst possibility, you find on the last place, that is the nth place you find it. So the best possibility is at first place, worst possibility is at the nth place. So if it is found, but if it is not found, then whether you call it best, it is order of n, you call it worst, it is order of n, because you have to reach end to declare that such thing does not exist. So you, on the way, you cannot say it does not exist, because it may exist where you stopped. So after that it may exist, therefore you can't just say it's does not exist on the way. In midway you have to reach end, only then you can say it does not exist. But on the way, wherever you find it, you can just stop it and declare that you find it at current position. So the best option would be getting at the first place itself, or the worst possibility would be getting on the last place. So if you talk about in terms of big O notation, then the linear search will have a big O of n. Then we have something called a binary search. And this requires sorted list. So the list has to be sorted. It is not that 4, 8, 10, 25, 16. No. So if you want the same thing, then 25 should come after 16, because it has to be in some order, either ascending order or descending order. So that has to be in sorted order. Then you look at the median of the sorted order and decide whether median represents your item you are searching. If so, so you got the answer. If no, then identify whether median is bigger than what you are searching or median is smaller than what you are searching. If median happens to be bigger than what you are searching, so this is the list you have, this is in sorted, and this is where you got a median. So if you know that your number is less than median, then the next step is you have to worry only about this part you can forget, if the item you are searching is less than median. On the other hand, if the item you are searching is greater than median, then this is what you need to worry about. This you need not worry, because you know that the item you are searching is greater than median, and you know that the list is arranged in ascending order. So if it is greater than median, then it has to be somewhere in this part only, so you can neglect this. So this happens when x is greater than median. And the advantage of working with this is the next step is you can use only this part or use only this part, and again repeat the same process. So we can apply recursion to this until we reach the point we get it. Or if you reach 0 level and still you don't get it, only then declare that such number does not exist. So advantage of this is each time you are dividing your workspace into half. Therefore, the worst case of this algorithm is log of n base 2. So the advantage, if you look at in the what you say, linear and binary, if you want to say, this is order of n, this is order of log n. So if you talk about n, then if you assume that each one takes a one unit of time, then if there are say 1000 items, then you need 1000 units of time to search in the worst case, and this you require only 10 steps to reach the required position. And if there are 1 million items, then you need 1 million search in the worst case, whereas this can be done only in 20 steps. And if there are 1 billion, then here you need 1 billion, whereas this can be done in just 30 steps. So same way, 1 trillion needs 1 trillion things, but whereas this can be done in just 40 steps. So you can see the power of binary search. So if you are talking about a current situation, then we have billions of data with us. So if you are searching for that, say, what do you think, how does a Google search will work? So there are billions or trillions of data with it, and when you are trying to search something on that, then if you look for linear, then it is going to take a billion or trillion of operations to do it. Whereas if you work on the binary search version, then within 30 to 40 steps you can do it. So that's the power of binary search. Now the question comes is, yeah, basically human is greedy. So the question raises now is from order of n, somehow we went down to order of, I'm sorry, log n. Now, is there any way to further reduce this? So if I want to further reduce this 10, 20, 30, if you want to further reduce, then only one thing is it should come down to a constant time. So that's the order of 1. So is it possible is the question. And if this is possible, yes, definitely we can think of doing the things pretty faster. So the next question we would like to ask is, can we search an item in almost constant time? The answer is yes. And if you ask how, so please wait for our next session. We are going to present that how we can get it in constant time. That's where the concept of hashing or bit what do you say, bit arrays come into picture. So the solution to this is there in what you call a bit array. So details of bit array we see in our next session. Till then, take care. See you. Bye.